Now let's look at the logistic regression. Logistic regression is used to model situations where growth accelerates rapidly at first, and then steadily slows to an upper limit. We use the command logistic on the graphing utility to fit a logistic function to a set of data points. This returns an equation in the form y equals c over 1 plus a times e to the negative bx, where the initial value of the model is c over 1 plus a, and the output for the model grows closer and closer to y equals c as time increases. So in Desmos, we'll be using y1 equals c over 1 plus a e to the negative bx1. For example 3, mobile telephone service has increased rapidly in America since the mid-1990s. Today, almost all residents have a cellular service. The table shows the percentage of Americans with cellular service between the years of 1995 and 2012. So this is the percent of Americans up to 95.28. Okay. Oh, up to 98.17. Okay. So we're going to look at this on Desmos. And we get this. Oh, I'm trying off the curve. So I plotted the data points like so. And then if I hit this, here's our y1 tilde c over 1 plus a e to the negative bx1. And it's given us our c is 105.737, b is 0.259547, and a is 8.92312. And the r squared is 0.9988. That's a really strong r value. So look at that curve. Fits really nicely in there. Okay, so we plotted the data, and I think we have a question here, don't we? We have some questions. Okay, hang on. So our first question is, let x represent the time in years starting with x equals 0 for 95. I said x equals 1, so we might be off slightly on the numbers might be a little different. And then y represents the corresponding percentage of residents. Okay, so we did that. Use the model to calculate the percent of Americans with cell service in the year 2013. So my modeling goes up to 12 or to 18, so it'll be the plug in 19 to get that. So we would have the amount at time t is going to be 105.737 divided by 1 plus 8.92312 e to the negative 0.259547 times t. So we're looking at it being 19. So a of 19 is 105.737 over 1 plus 8.92312 e to the negative 0.259547 times 19. And that's going to be, let me get the calculator out. I'm going to get 99.34%. Okay. And if you were to look at the book data, theirs was a little different, but they started at 0 instead of 1, so it could have thrown those numbers off a little bit. And the last question, discuss the value returned for the upper limit c. What does this tell you about the model? What would the limiting value be if the model were exact? Well, look at this c. So c is C is 105.737. This means that in the long run, 105% of the population is going to have cell phones. So 105% of the 0.7, by the way, of the population will have cell phones. And that's not possible. So it's the model's not perfect on that. Seems to be fit the curve real well, but we're never going to get to 100%, over 100%. So that's it on the logistic model.